Hello, my name is Kiran Joni. Today, I'm going to introduce you to the Eso-Loop Framework, an entrepreneurship self-organization framework for a complex, dynamic, and interconnected world. Eso-Loop Framework is a complexity theory-based design solution to aid entrepreneurial action. Entrepreneurship is a complex decision domain, so it makes enormous sense to design something based on complexity theory for a domain like entrepreneurship, instead of relying on reductionistic, one-size-fits-all approaches like lean startup, business planning, or some kind of incrementally improved versions of these ideas, or some ideas that were already in existence that got overlooked in the past, like, for example, the probe and learn approach. None of these approaches are based on complexity theory. None of them claim to be. Many of these approaches are not based on the fundamental understanding that entrepreneurship is a complex decision domain. Most of these approaches are coming from extreme case of reductionism and narrowed disciplinary specialization. In most cases, specialization happens first, and based on that specialization, a design solution is developed for a real-world complex adaptive system like entrepreneurship. It is based on the false assumption that the reductive abstraction of a disciplinary specialization is going to be able to represent a real-world complex system like entrepreneurship. This is far from the truth, but the problem is that most of these approaches are coming from that kind of epistemology. Even approaches like effectuation theory, which I personally consider to be, to some extent, complexity friendly because of the flexible heuristics nature of this approach. The problem is that effectuation theory is not based on complexity theory. Effectuation theory is based on expertise theory, because entrepreneurship is an unstructured complexity domain. Expertise is not possible in an unstructured complexity domain. Expertise is possible only in a structured complexity domain. There should be some kind of structural stability in a system to enable the acting agent to pick up the rules of the system, learn about the patterns and dynamics of the system, and do this for a long period of time to become an expert at that particular system or domain. There must be enough opportunities to get feedback, immediate feedback. That is also very important. The acting agent should be able to connect a particular action with a particular feedback from the environment. That's how the agent will learn and ultimately become an expert. This is not possible in an unstructured complexity domain like entrepreneurship. In an unstructured complexity domain like entrepreneurship, there is no state space stability. There is no environmental stability. There is no structural stability. There is no goal stability. Even goals are evolving and co-evolving all the time. There is no feedback stability. You did something at a particular point of time, you might get a positive feedback. Another point of time, you did exactly the same thing, but you might get a negative feedback because of the context sensitivity. So entrepreneurship is thus can be considered as an extremely complex domain. Entrepreneurship is a typical example of a high uncertainty, high novelty, high emergence system. Entrepreneurs are operating in the evolutionary edge of social emergence. So most of the things which entrepreneurs encounter as entrepreneurship core activities are not going to repeat again. And without repetition opportunity, there is no possibility of becoming an expert at that particular thing. There should be some kind of stability in the system that enables that kind of repetition opportunity and ultimately leading to development of expertise. This is not possible in a domain like entrepreneurship. So because of this level of complexity, we need a complexity theory-based design solution for a domain like entrepreneurship. That is why I designed the Eso-Loop framework based on the theoretical foundations of complexity theory, particularly self-organization theory, taking inspiration and insights from various applied complexity models. Now, this was an introduction video. In the upcoming videos, I'll be discussing much more detailed aspects of this framework. I'll be discussing the inspiration for the design of Eso-Loop Framework. I'll be discussing the theoretical foundation, the design logic, and also the dynamics of the framework. Now, the paper which I'm basing this presentation is available at GitHub pages at the URL isoloop-framework.github.io. The citations which I use in this presentation is also available at this URL, unless it is already displayed on the screen. That means it might be a fairly new citation. So that's the end of this video. See you soon in the next video.